Show you something cool. All right, so I gave you everyone saw the reviews. Oh, the review assignment has an issue. It sounds like.
Yeah.
Okay, here, let me fix that real quick here.
Code 14.
I guess I need to record. This is where I showed you folks the trick about using the calculators in the reduced row echelon form. Okay, and all this would be, you can do this on your calculator, and that is the best way to do it. The way I showed you is far and away the best way. So you would just build, you'd go to matrix A in your calculator, and how big of a matrix would you build for this one?
5 by 5.
5 by
Six.
6. Because you'd need 5 rows, and you'd need 1, 2, 3, 4, 5, plus 1 for the constant. You'd need 6 columns, right? And then you would do the very same thing you did before. You would just put in that, you build that 5 by 6 matrix. All the rest of the steps would be the same. You just would go to math, reduced row echelon form, matrix A, if that's what you're using. And it's going to give you back, same rules. If it gives you back a solution, you're just going to get, the matrix it gives you back, it's going to, the first square part of the matrix, the first 5 by 5 section is going to be what we'll eventually come to call an identity matrix. It's going to be all zeros with just ones diagonal, right? Which just means 1 times V equals whatever that number is at the far right. 1 times W equals whatever that number is. That's the best way to do it. But for some reason, that one's not, I don't know, reduced row echelon form is a great trick. But a lot of times, people don't use it. I don't know why. They should. But like, for example, now, I just found this yesterday. I'm really psyched about this. Desmos is building a beta version of a matrix calculator. It's really cool. So that's likely to be what you're going to use probably from here on out in a lot of your classes. So you need to learn how to use it, right? And I'll use it on the test. You can do the same kinds of stuff, but it's a slightly different procedure. So I want to show this to you. So you got to really close these up. You got to really pay attention. So if we're trying to solve something like this, and this is, I will give you one that big. This is really huge and ugly and big. But I mean, it doesn't really make any difference. You can do, when you're using matrix methods, there's just more of a chance to make a mistake inputting numbers. I don't want you to do that. But you could make this, this could be a 9 by 10 system, really, and it's, you could do the same thing on a calculator or on a computer. They've got the processing power to crunch those numbers and perform the row operations and give you an answer relatively quickly, right? This would take you a long time to do by hand, though, as we talked about, right? There'd be a lot of steps involved in this, and it'd take hours and hours to solve this one without using matrix math, right? Which we don't really know yet, but the calculator is. Here's how we can approach this, though. We can set this up as a matrix equation, okay? Now, here's how we'd set up a matrix equation. What we would do is we would write this in 2 parts. We'd write this as, we're going to call this, how about matrix A is going to be it's going to be the variable portion of this. It's going to be the first 5 rows and 5 columns, okay? So matrix A then would just look like, it's the coefficient matrix. And it's going to look very much like what you're used to. It would just be 4, -2, -1, 2, 5. See what I'm getting at? Just the coefficients of the variables in increasing order. Now, what happens if we're missing like an x term there? What's the coefficient? 0, right? But you'd have to include a 0 there. Does that make sense? Okay. So then we get 3, 5, 2, -1, -1, -2, 2, -3, -3, 1. That is a little too big. This takes too long. I should have made it a little smaller. Oops, I'm missing one here. Well, I'm missing the W, right? Yeah. So I got to go back. Okay, so I got to go back to this row.
Dude, it's so
And I've got to have a 0 right there, right? And then we've got a -5, -2, -4, -2, -2, 3, 2, -5. We'll call that matrix A, okay? We're going to call matrix, we'll call this matrix X for our variable matrix. Let me go so matrix X is gonna be, it's gonna be a column matrix. All it's gonna be, it's only gonna have one column, but it's gonna have a row for each variable. So it's gonna look like this. It's gonna be a 5 by 1, and it's just gonna be V, W, X, Y, Z, like so, okay? And then we're gonna define, just call this matrix B is gonna be the constant matrix, which is just gonna be all of the numbers on the other side of the equation, okay? And that one's gonna be another 5 by 1 matrix, and it's just gonna look like -4, 10, -11, -35, and 10. Okay? Now, for reasons that I don't want to get into all the matrix stuff, because we really don't have time to do that. At the end of the year, if we've got a little gap, this would be a good thing for me to show you. We could talk about it. It's really, because almost all of you are going to, I'm assuming, going to go on in math, and so at some point you're going to see this stuff. Right? Not in high school, but you'll see it in college. And so it's nice to have a little bit of an understanding of what this stuff is all about. Yes, sir.
Wait, so why can't we do like a 5 by 6?
Well, you can, but you can't on the, good question. Why are we going away from that? Because on the Desmos matrix calculator, they don't give you the ability to do the reduced row echelon form, to convert something to reduced row echelon form. It's too bad they don't. I'm gonna give them some feedback on this. They were recruiting feedback from mathematicians, and so I'm gonna actually draft a little email to them about why I think they should include that. And hopefully they will, but we'll see. I mean, I'm not holding my breath either. Okay, so if I define these matrices though, here's what's really cool about this, and this is the part I want you to make a connection to, because someday you're going to look back on this and say, oh, okay, now I get what he's talking about, and this will be helpful to you in the future. We can write this whole thing up here. I can replace this whole system then with the matrix equation, matrix A, and I'm just going to represent it like that, times matrix X equals matrix B. Okay? So the coefficient matrix times the variable matrix equals the constant matrix. Okay? Now think what you would do in a regular old situation if you just had a non-matrix equation. What if I just had the regular equation A times X equals B? How would you solve for X?
Divide by A.
You'd divide by A, wouldn't you, right? Okay. Dividing by A is the very same thing as multiplying A by its multiplicative inverse. What's the multiplicative inverse of A? 1 over A, right? So division for regular real numbers is exactly the same thing as multiplying by the multiplicative inverse, which is just the reciprocal, okay? It's the same kind of a pattern with matrices, but matrices, as you can see, are a little more complex. So we don't just divide by matrices. What we have to do the corresponding thing, we have to multiply by the inverse matrix to get rid of something, right? So just like we would say for real numbers, A times 1 over A equals 1, which is what we're trying to do. I'm trying to get a 1 times X equals something, right? So I could multiply 1 over A times both sides and get 1 times X equals, that's supposed to be an A, isn't it? Equals B times 1 over A. Everybody with me? And we would just think of that as being B divided by A, and that'd be our answer. We're going to do the same thing with matrices. Okay, but an inverse matrix is more complicated than just taking a reciprocal. To take the inverse of a matrix, there's a whole process you got to go through to find the inverse of this matrix. You got to calculate determinants, and you got to, there's a whole, it's a big process, right? But calculators or computers do it instantaneously just about, right? And it's, once again, this is stuff that, if we have time, we'll do some simple matrices at the end of the year, some smaller ones. But that's something you'll learn when you get into your matrix theory class eventually in math, right? Okay, so all we want to do here then is we want to undo this A and replace it with the matrix equivalent of 1, which is just the identity matrix. And it's just a bunch of 1s in a diagonal and then 0s everywhere else. And here's the thing though, when you multiply matrices, they're not commutative. matrix A times matrix B is not the same thing as matrix B times matrix A. The order is critical. You have to do it in a certain order. So when I multiply matrix A by its inverse, I have to multiply each side of this equation by the inverse from the direction where it's going to be next to the A. So I couldn't multiply from the right side by the inverse of A because X probably won't multiply by the inverse of A. But A will always multiply by its inverse. So because the A is on the left side of this product, and it makes a difference, weirdly enough it makes a difference, I've got to multiply from that direction by the inverse matrix. Okay? This is going to be weird to you, but just trust me on that one. Right? I got to do the same thing on both sides. So then we're going to get, when I do that, I'm going to get A inverse, and that's how we represent it. A inverse times A times X equals, now I got to multiply from the right on the other side of the equation also. So I've got to multiply A inverse times B on the other side. Okay, this stuff right here does what we'd expect it to do. That essentially cancels out A. That just becomes what we call the identity matrix, which is just like 1 in matrix terms. So the identity matrix times matrix X equals this stuff. And the identity matrix times X is just X. So then finally we get down to where the variable matrix X equals A inverse times B. Okay, why do I show you all that? Because it works the same way every time. The same way every time. So I can take any system, and if I can set it up as, we'll call A the coefficient matrix, we'll call X the variable matrix, and we'll call B the constant matrix. It could be a 5-variable system, it could be a 20-variable system, it could be a 2-variable system. It doesn't matter. All you have to do is define those matrices and then just ask the calculator to do that. Because that's always what the variable matrix is going to end up being equal to, okay, every time. And so I know a lot of this stuff probably didn't make complete sense, but trust me, someday you'll look back on that and think, okay, now I kind of get what's going on. But let's just try this trick. So if we use I'm going to pull up the new matrix calculator. So there it is. And if I grab this thing, notice it's in beta, so you can send them feedback too if you want to. Tell them how cool it is.
Can you really just say that it wasn't?
And so let's try this out, right? So we want to, let's go up here and let's write out all our matrices.
Yay.
Okay, so we're going to do a new matrix, and I'm kind of just figuring this out as you guys are too. I've only just messed around with this very, very little. So what do we want our matrix A to be? How many rows and how many columns?
5 by 5.
5 by 5, okay. Boy, we're about maxed it out there. 5 by 5.
Wait, how do we do
So we'll add a 5 by 5, it automatically calls it A, and then we're just going to plug in all the coefficients, right? You can do this with me if you wanted. That's fine, I don't care. If you want to. If you want to do this, you have to go into, the only place I have that matrix calculator right now is in the review. If you want to go in there and try it, you're welcome to. Or you can just watch it, that's fine. Maybe just watching is easier.
Are you going to put it in?
I'm going to put it in.
For the test?
So, no. And then when I'm putting these in, I think I just have to go, this is all new to me, I think you just go use the left arrow and right arrow. So you read them off to me. 4,
-2,
-2,
-1, 2, 5, 3,
and then did it work? Okay, it went down. Okay, good. 3,
5, 2, -1, -1, -2,
2,
2, -3.
-3.
I'll let Andrew do it.
Okay, Andrew, go ahead. -3. Keep going then. You're on.
-3. 1. -3.
Hold it, are you sure? We got a 0 there, don't we?
Skip one, 0.
Because we got, see, we're missing a W there.
We're
Okay.
at negative 5,
Okay, -5.
negative
That
2,
isn't right.
negative 4, negative 2, negative 2, 3, 2, negative 5.
Okay, so there's matrix A.
Oh, wow.
Okay. Now we need a new matrix.
So we don't have to put what's equal.
Yeah.
So now we need matrix B, don't we, right? We don't need to input matrix X because that's going to be what our answer is, right? Remember what we had here real quick. Our answer is going to be in the form the variable matrix equals, but this is what we need. We need to put in matrix A and matrix B we need to put in there, right? So then we'll go, now we need a new one. This one's only going to be, it's 5 rows by 1 column, right? Okay, we'll call this B. And, oh shoot, what's B? I gotta go up.
Oh, shucks.
Okay. So matrix B,
-4.
where am I? There we go, hold it, what happened? There we go. Matrix B is -4.
And -11.
Oh shoot, hang on, that's not working.
Uh-oh.
Okay, I gotta go either down arrow or right arrow, I think. 10.
-11.
So you gotta use the arrows. You can't hit enter.
10.
And 10, or tab would work, yeah. Okay, and so now I'm gonna go down, I'm gonna hit enter and go down to the next line, and I wanna do A inverse.
Oh.
And so I'm gonna pull up matrix A, I'm gonna hit the inverse button, and look what it does, it actually gives you the inverse matrix right there. So that's what the inverse matrix would look like. And then I'm gonna multiply that by matrix B. And look what it does.
Whoa.
How cool is that?
Oh my god.
It's telling you, those are the values of the 5 variables.
That's what I got. See, that seems like a lot more work than just entering it into the thingamajiggy on your regular calculator.
I agree, but your regular, so for the testing purposes, it's a lot easier for me to build a test where I can build the calculators into the test. And I was wrestling with this last night thinking, man, I like you knowing how to do them on the calculators, but I guarantee if this is on Desmos, this is what you're gonna do in college a lot, because that's what, they're gonna use the Desmos calculators. They're becoming kind of the reference standard. And eventually they'll probably add that stuff to it, but they just don't have it now. I mean, it's still being built.
Can you like use
Okay, does that make sense?
Desmos is on the sky.
How do you,
Shut it down.
Okay,
just on the regular calculator, how do you give it to like,
Desmos isn't on.
well, let me answer your question individually.
okay.
So, okay, so we're good, I'm gonna let you work then. Is that enough to get you going on this, you think? Okay, then I'm gonna let you work. I'll let you work and we'll tomorrow, we'll maybe, whatever you're having trouble with, we'll go through, but I'll let you need today to just work. Okay. To solve that, you're just solving it like just.
I don't want to hear it. Right?
That's too low. That's too low.
I mean, you can do that. Yeah, I
respect my
So like say X. Oh.
Oh, you have to do. So you go to. And then you get the variance. But on these.
Satisfied.
You know I'm right.
Oh, that's.
I mean, you're not working on it, right?
You have like
Very
different.
Okay.
Because there's a row of.
You can't spend that's not possible. You can't spend more than $12. Can't spend more than $12, Shaylin.
You don't have to.
You only made one. There's gotta be. There's gotta be right. Be right.
No, I get what I'm saying. I get what you're saying.
Hey.
Yeah. Oh, so you just Yeah, I think they really close kind of. And so yeah, so now it's. Are you going for the? Are you going for the? Are you going to the regular? This is the regular. Yeah.
Is it?
Don't think so.
Upper echelon frame, REF or RR?
He said it's
It's
good.
RR.
That's why we. Okay, so what do you do again? Oh my god, here. Okay, so matrix.
Well, you might have done it.
That's better.
Yeah.
Wait, that's it? George, I'm not gonna let you touch this anymore.
No, red stuff just do is sign it. Oh, never mind, check my.
That?
Yeah.
Oh, okay.
So
gonna
it's
do,
red,
it's
zero
at
sign
5 by 6.
Orange means it's major.
So, no, that's alright. All you need to do is add the coefficient, or whatever that is.
Oh.
And then do everything, and then you'll get the size.
So it's like -4 and then.
Yeah.
Yes, it did.
Okay, thanks.
Or yes, it did.
Yeah, it was. But it wasn't you correct my mistake. It's all your fault. I hate you, George. Never talk to me again. You're a bad person. Hate you.
Hey, what are you doing? You haven't done that yet.
What do you do?
No. That's against the rules. It's against the rules. You can only highlight one. That's the same thing that you have.
No, I don't.
You have a keyframe, which you have.
How do you do this and then go to the map?
That's not, that's.
Oh.
Anyway.
You do that backwards.
Once you're done with that.
You look. Subtract X. You got negative
Okay.
5 y.
Select.
Yes.
Okay, so you got, from those two, you got the same, so when you add those up, you need 0, 0.
5, 5,
So it's gonna be,
y.
does that make sense? Okay.
Negative 1 bit x.
Yes, ma'am.
Yes.
Hey, buddy.
Okay.
So great.
You did it right the
The
first
answers
time.
are just this, right?
Linear inequalities, okay, so,
Thank you.
Absolutely.
Because when I get y is greater than
Bottom
one,
right.
well, you just try to, you're just gonna find, when you graph this thing, you're gonna get something that's not gonna be out there.
I did not sniff his coochie.
I could graph this by finding the x-intercept. If I said that x equals 0, I get 12 divided by 28. And that's gonna be, it's gonna be 15, exactly. And when you let y equals 0, you're gonna get 12 divided by 0.24, which is gonna be like,
You know what? I'm
50.
done.
Okay. So you get points on there that you can use with net, right?
So those answers for mine are the order that like
Y
here, so like
is.
here it would be VW X, Y, Z.
So, when you put it in.
Less than one. See what I'm saying?
So what is like
You
the
could, actually, you don't even have, you could just write it in standard form, but you wanna always
Yeah.
have the.
Oh, the
number.
answers?
I
Oh,
grabbed
so, like each one represents a
You can
variable.
graph, yeah.
So the first
Okay,
one
that's what I
is the
thought.
V.
Yeah, that's what I was
Second
saying.
one's the W. Yeah.
Okay,
Well, you're gonna,
that's what I thought.
you might change the scale, maybe to, you know, I mean, possibly. Because I think it's, I would go, because you know, these are pretty
At least you have.
small numbers on that scale, you might make
I have no dads, no moms. I'm adopted son.
like going by, instead of going by camps, so it spreads it out really easy, it's really easier to see.
Yeah.
Honestly, Shannon, I wouldn't be surprised